In our next section, we're going to talk about equivalent and countable sets. Equivalent might be something different than you've studied before in your basic set theory class. But let's introduce this by taking an example of a set A and a set B. A is a set 3, 4, 5, and B is a set 9, 12, 15. And let's compare those sets. Well, obviously, they are not equal to each other. And we know that A is not a subset of B, and we know that B is not a subset of A. That's a great way to compare them. Well, one thing that we do know about them is, and this is very important, they both have 3 elements. That means they are equivalent, and I'll formally define that in a minute. Okay, they both have 3 elements, so there exists a one-to-one and onto function that maps the elements of A onto B. One-to-one and onto, we call that function a bijection whenever it's one-to-one and onto. And let's give an example. I'm going to define the function f to be the set of ordered pairs that maps 3 to 9, 4 to 12, and then 5 to 15. That is one-to-one and onto function. An interesting question would be how many such functions exist? Well, I think the answer would be 3 factorial or 6. You could map 3 to any one of those 3 numbers, so that's 3 different ways. And then the remaining one, 4, you could map to any of the 2 remaining numbers, and then 5 you would be kind of pigeonholed into choosing the only remaining one. 3 times 2 times 1. You could write them out if you wanted to. It would only take you a minute to write out the 6 possible one-to-one and onto functions. Another way we could write this is simply f of x is equal to 3x for all x in the set A. These 2 are equivalent functions. Notice that 3 times 3 gives you 9, 4 times 3 gives you 12, 5 times 3 gives you 15. I'm going to squeeze one more definition down here, formally defining what equivalent means. Sets A and B are equivalent and that's what we're defining, equivalent. And let me show you how we denote that. This is A is equivalent to B. The little squiggly looks like a tilde. If there exists a one-to-one function from A onto B. Just like we showed in this previous example, a bijection from A onto B. And it should be easy to see that if there is a function, a one-to-one and onto function that maps A onto B, there is also one that maps B onto A.